Hello everyone, good evening all. How are you? This is your KP sir on live. So before going to start the session, I will have a small announcement on Unacademy in Plus course, means a paid course. Plus course is a paid course. Yesterday only I have started a full-length course on irrigation engineering. Here, yesterday only I have started the full-length course on irrigation engineering. And again from August 24th, I am going to start engineering hydrology. So you have not yet taken Plus subscription, join as early as possible. Don't miss the opportunity. And this is a full-length course for both irrigation engineering and engineering hydrology. This is a full-length course which will teach you for GATE, ESC, APPSC, whatever state government exams, AE, AEE, and also SSC, JE. It covers for any competitive exam a single solution full-length course, irrigation and engineering hydrology. Irrigation started yesterday. Engineering hydrology will start from August 24th. So take your Plus subscription as early as possible. Use my code KPCivil. So is everything clear? Yes, Banu, it is a full rain in Hyderabad. Heavy rainfall in Hyderabad, Banu. So is the voice, video, everything clear? Yes, we'll move on. So we have completed 4 sessions already for engineering hydrology. Engineering hydrology only, again I am clarifying, only for AE, AEE, it is not for GATE, ESC. The standard what I am teaching, the depth what I am making you to learn here, only representative for AE or AEE only, not for GATE, not for ESC, okay? No. We'll move ahead. So what we have finished is related to in the previous session, mean precipitation calculation, missing rainfall data determination. We have completed mean precipitation calculation and missing rainfall data determination. Now today we are going ahead. Presentation of rainfall data. Presentation of rainfall data. Yes, by the end we will do, Banu Prakash, for all at a time all questions will solve, so that only in exam also you are not having topic wise questions, no random questions. Like that I will give the model of exam here, so that you can experience the feel of exam here itself. Okay. Presentation of rainfall data. The first one, rainfall data is presented, the most important one, hyetograph. Hyetograph. What is a hyetograph? The graph drawn between intensity of rainfall, against time. For how many rainfalls? Hyetograph is drawn for how many number of rainfalls? Tell me. Yes, rainfall intensity versus time. Good evening, Rahul Kumar. Hyetograph is plotted for how many number of rainfalls? Any one of you tell me. No answer. No answer. Hydrograph for how many rainfalls? For a single rainfall. For a single rainfall. For what purpose? For what purpose hydrograph is helpful? To understand infinite, Rahul. It is not infinite rainfalls. It is for only for one rainfall. Fluctuations of rainfall. Fluctuation, to understand fluctuations of rainfall for its duration is called as hydrograph. Hydrograph. I will tell you in simple manner. Today rainfall occurred for 8 hours. The rainfall depth entered into the ground level. First hour, second hour, third hour, fourth hour. Will the values are same? First hour rainfall falling depth, second hour rainfall falling depth, third hour rainfall falling depth, last hour rainfall falling depth. Is it same? Hour to hour, is it same? So rainfall values. Values you may consider as depth, values you may consider as yes, good evening Rudrajay Singh. Values you may consider as depth, values you may consider as intensity. Variable, time to time, hour to hour, time to time or hour to hour you can take. The change in rainfall occurrence per each hour. What is the rainfall depth per hour? That is called intensity. No? Rainfall depth taken, depth of rainfall per hour, which is called intensity. So we are determining intensity value of rainfall for each hour. We are determining the intensity value of rainfall for each hour, and that is plotted as a graph. What is the mode of graph we have plotted here? This is the mode of a graph we have drawn. That is the mode which is called bar diagram. Bar diagram. No? The mode of graph what we have drawn here as a bar diagram. So first hour, second hour, third hour, fourth hour, it is varying, increases. And after reaching maximum, again, 6th hour, 7th hour, 8th hour, fall down. That increase and fall down, raise and fall down. Initially rainfall is low, slowly increases and reaches to peak, and again slowly fall down and reaches to zero. From starting to ending of rainfall. Got the point? From starting to ending of rainfall. The rainfall values initially low, rises up, reach peak, maximum. And after reaching the peak maximum, stay for some time, immediately, again slowly, fall down, finally zero, end up. That is shown in a hydrograph as a bar diagram. That is going to be represented in a hydrograph as a bar diagram. So we are going to consider intensity of rainfall. Which units? Intensity of rainfall on y-axis, time in hours on x-axis. Intensity of rainfall on y-axis, yes, correct. Anurag Dayal Pandey. we are considering fluctuations for one rainfall. Whatever variations, changes, whatever analysis, only for one rainfall, single rainfall. Yes, very good, Rudrajay Singh. This is mm per hour, intensity units, mm per hour. You understand, Anurag Dayal? The fluctuations, variations, modifications, whatever done, whatever analysis you are carrying out, whatever values you are expressing, everything related to only one and only one rainfall, single rainfall. Now, so I am taking here, this is the first hour rainfall intensity. This is the second hour rainfall intensity. Third hour rainfall intensity. Fourth hour rainfall intensity. Fifth hour rainfall intensity. Sixth hour. Well, all values are same. I1, I2, I3, I4, I5, I6. We'll write down. No? We'll take like this. I1, I2, I3, I4, I5, I6. Will all values are same? Rudrajay Singh, PDF. For this, how can I give the PDF to you? YouTube session, whatever I have drawn. If I have typed, PDF is available with me. If whatever I have drawn, I have written, that is not going to save YouTube session. In Unacademy, they have a separate software for it, so that it was saved as a PDF and you can be downloadable for it. But in YouTube session, it is not possible for you to provide these pictures, no? Because I have drawn. If it is a picture given, okay, it is with me in the PPT, I will send you PPT. So it is not possible because YouTube is not providing that facility. Not possible means YouTube is not providing that facility. So we are going to have only whatever I have written, you write down. If you need questions, the slides which shows objective questions, I will send it, Ajay Singh. You send a message to me, I will send slides with questions. But whatever I am writing, it won't come to you. Okay? So time in hours, intensity in mm per hour we have plotted. I1, I2, I3, I4, I5, I6. This is hyetograph for one rainfall. Okay, what you are getting by this? What you are getting by this? First of all, from the picture, you came to know what is the hour at which maximum intensity of rainfall occurred. This is the value of maximum intensity. Na? This is the value of maximum intensity. Na? And this is the minimum intensity. Na? So highest depth of rainfall per hour, lowest depth of rainfall per hour. Both maximum and minimum intensity values related to a single rainfall. Within the same rainfall. We are not talking about 2 rainfall, 3 rainfall, 5 rainfall. No. Within the same rainfall, whichever gives highest depth of rainfall, highest intensity. Within the same rainfall, whichever gives lowest depth of rainfall, lowest intensity. Maximum and minimum intensities of rainfall shown by hyetograph. Is it clear for everyone? Shall we move on now? So what is this hyetograph is going to provide? What is this hyetograph is going to provide finally? Very important. The hyetograph will provide you information total depth of rainfall and also average intensity of rainfall. Yes, and also average intensity of rainfall. Adjusting phi index is a complicated process. Don't go for it. In a simple manner we are getting here. Adjusting. So how to determine total depth of rainfall from hydrograph? Total depth of rainfall from hydrograph. First condition, total depth of rainfall from hydrograph. First condition, delta T is uniform. This delta T is uniform, tell me. Here what is difference? 1 hour. Here what is difference? 1 hour. 1 hour only, no? So uniform time interval, you have taken change in time from 1 bar to second bar to third bar to fourth bar. The change in the time interval is considered to be uniform time difference. So in such a case, depth is equal to, simple, no? I1 plus I2 plus I3 and so on, In, sum of intensity values into delta T. Sum of intensity values, summation of II into delta T. This is the condition where delta T from one bar to other bar, all bars can show same uniform time duration, uniform time intervals. Then, if delta T is non-uniform variable, delta T is non-uniform or varying from one intensity to other intensity. Variable varying from one intensity to other intensity. Means it is not 1, 2, 3, 4, 5 as written here. It may be, I will take, for example, here it is 1, then it is 3, then it is 6, then it may be 7, then again 12, then again here 16. So what is delta T? Is it same? Delta T is it same? Tell me. According to this given values, 1, 3, 6, 7, 12, 16. According to the given values 1, 3, 6, 7, 16. Delta T here is 2. Delta T here is 3. Delta T here is 1. Delta T here is 5. Delta T here is 4. So what are delta T values? Variable not 2, 3, 1, 5, 4. Non-uniform variable. In such a case, how we will get depth? Depth is equal to I1 delta T1 plus I2 delta T2 plus I3 delta T3 and so on. In delta Tn. So we can write it down as a summation of II into delta Ti. Summation of multiplication product of individual intensity and individual difference in time. Summation of II into delta Ti that is change in time for non-uniform or variable change in time, depth of rainfall. Got it? The same when we consider delta T is uniform, same we can write down average intensity of rainfall. Simple. I1 plus I2 plus I3 and so on. In by n. So delta T is uniform. Here change or time difference is the same, uniform. Average intensity, you can take it simple mean. I1 plus I2 plus I3 and so on, In by n. But if it is non-uniform, in this case, change in time difference is non-uniform, average intensity. Change in time difference is non-uniform or variable, average intensity. Average intensity is equal to, already you have derived total depth. From where you have derived? Using this formula. No? Using this formula you have derived total depth. That total depth by duration. Average intensity is equal to total depth by duration. So that total depth by total duration will consider non-uniform time, variable time. Understand? Not the same formula for average intensity. First one simple arithmetic mean of all intensities. Second one use the total depth by total duration, will get the average intensity. We'll solve one question here. Here itself we'll solve the question because these models till now in any AE, AEE, till now these models are not provided. Don't worry. Okay. By chance if they have given. You understand? In any state government AE, AEE exam, related to numerical question related to hyetograph is not given. But hyetograph is a intensity versus time. This is most repeated question. The most repeated theoretical question always provided regarding hyetograph, this one. Hyetograph is a intensity versus time. By chance this year they want to change the pattern. Suddenly they will give numerical question. So for that now we are going to solve one numerical question related to it. Okay. Same intensity mm per hour. Time in hours. Intensity mm per hour, time in hours. We are going to have the values. So intensity values are given here. This is the hyetograph provided for you. This is the hyetograph provided for you. What you need to estimate, what you need to determine. You have to determine total depth, maximum intensity, average intensity. This is the question. Clear? You have to determine total depth, maximum intensity, average intensity. Now, total depth. The time is uniform, non-uniform. The time is delta T. Delta T is uniform, non-uniform. Tell me for this question. Delta T is Any one of you tell me? Come on. I'm waiting. Come on. Delta T is uniform, non-uniform? Very good, Rahul. Yes, uniform. Delta T is 2 hours. Is it not? Delta T is 2 hours now? Clearly. Delta T is 2 hours. Total depth now. So simple. I1 10, I2 15, I3 25, I4 20, I5 10 into 2. This is the value. 10 plus 15 plus 25 plus 20 plus 10 into 2. So what is total depth? 160 mm. 160 mm. 160 mm total depth. Any doubt? Maximum intensity? It is for sure 25 mm per hour. Maximum intensity, no doubt, na? Always highest bar is representing maximum intensity here. This is 25 mm per hour. That is maximum intensity. Now, average intensity. This is average intensity. 160 by 10 hours. 16 mm per hour. 16 mm per hour. Maximum intensity 25. Average intensity 16 mm per hour. Total depth 160 mm. So is it clear for everyone? Shall we move on now? You got the clarity related to it. We'll go ahead. We'll go ahead. Second one, rainfall mass curve. It is a rainfall mass curve. Rainfall mass curve. The plot drawn between cumulative depth of rainfall, cumulative depth of rainfall. What we call that cumulative depth of rainfall? The plot drawn between cumulative depth of rainfall. Nothing but accumulated flow. Cumulative depth of rainfall. Nothing but accumulated flow. Simple. Versus accumulated flow versus time. Accumulated flow versus time is called as rainfall mass curve. Rainfall mass curve. So these 2 points are very important. Sometimes they will give you cumulative depth. Sometimes they will give you accumulated flow. Both are same words. No change. Here, just alternate words. Cumulative depth, accumulated flow. Both are exactly as it is same. Alternate words. So you are plotting. You are going to plot a graph. Same time in hours on x-axis. Y-axis cumulative rainfall depth. Will you tell me, is it for single rainfall, several rainfalls? Will you tell me? Come on. Is it for single rainfall, several rainfalls? No answer from anyone? So this is also for plotted for 1 rainfall. For a single rainfall, first hour, second hour, third hour, I will write. Oh, not for several. Banu Prakash, Rahul, Rudrajay Singh. For a single rainfall, we'll take here a 10-hour rainfall occurred, and for this 10 hours, each 2-hour duration we have plotted. Depth in mm is taken, each 2 hour we have taken. Depth in mm we have considered, and these are the individual depths we got. Okay, this is a single rainfall happened for 10 hours. Rainfall mass curve, it is not double mass curve. I am not talking about double mass curve. Only I am talking about rainfall mass curve. Clear? You are plotting rainfall mass curve in a recorded rain gauge. Will the recorded rain gauge will give several rainfall data or first rainfall data? You understand the question? Okay, now the data is there. Rudrajay Singh, you have taken the formula here, 160 mm total depth. Total duration 10 hours na Rudrajay Singh. Total duration 10 hours here, 160 mm total depth by total duration 10 hours. Or you may take intensity values. You can solve like this also. You can solve like this also. Average intensity is equal to 10 plus 15 plus 25 plus 20 plus 10. How many variables? 5 variables. 1, 2, 3, 4, 5 variables. Still you get 16 only. Still you get 16 only. You understand? By using the two formula you can solve for this. For delta T uniform duration, you can take first formula sum of intensities by time. You can take second formula total depth by duration. Any case you will get it. Now, this is a 10-hour rainfall. This is a 10-hour rainfall. Happened individual depth. These are not intensity values, individual depth for every 2 hours. Now we are writing cumulative depth. Now we are determining cumulative depth. How can we write down cumulative depth? 0, 0 plus 4, 4, 4 plus 6 total, 0 plus 4 plus 6, 10, then 10 plus 12, 22, 22 plus 6, 28, 28 plus 2, 30. So these are taken on y-axis. These are taken on y-axis. Will the values are cumulative depth y-axis values are several rainfall values, single rainfall value. A single rainfall happened for 10 hours. For each 2 hours you have the data. You understand? Single rainfall happened for 10 hours. For each 2 hours you have the data. You are solving it. 0, 4, 10, 22, 28, 30. Now you are plotting. It started with 0, 4, 10, 22, 28, 30. What is the last value? Last value is 30. It is given as total depth. Yes, very good. Prakash and Rahul Gautam. This gives the total depth. The last value is going to provide us total depth of single rainfall. Last value is going to provide us total depth of single rainfall. Now, so what the output provided from a rainfall mass curve? Always, very important this point, rainfall mass curve, always rising curve. Anyway, it is possible to falling curve rainfall mass curve under any circumstances. Is there any possibility? Is there any possibility of rainfall mass curve to have a falling curve? No, it is always rising curve. Always goes on increasing, always rising curve. Its final output is, what is its final output? Provides total depth of rainfall. No, slope does not represent intensity. Manu, what you have taken slope? Slope is you are taking y values, y ordinates. Slope is y ordinate. What is y ordinate? Y ordinate is cumulative depth. It is not at all representing intensity. You are taking 0. So this is 0. So take here 4. So this one, this is 4. This is 10. This may be 22. This is 28 and that is 30. You understand? It is not intensity. It is clearly mentioned y ordinates. Cumulative depth of rainfall. It is not intensity values. Third one. DAD curve. This is a DAD curve. Depth, area, duration. Depth, area, duration curve. This is y by v. Prakash, Banu Prakash, what you have written y by v? DAD curve, depth, area, duration curve. So first what we are making under first circumstances, kept area as constant. You keep area as constant. For example, take the area of catchment 250 kilometer square. Area of catchment 250 kilometer square. Now, rainfall occurred for 10 hours. Rainfall occurred for 30 hours. Which will give more depth? $10-hour rainfall will give more depth, 30-hour rainfall will give more depth. In the first case, you kept area as constant. Same area of catchment is not at all modifying, 250 kilometer square only. Rainfall occurred into 250 kilometer square area for 10 hours. Rainfall occurred into 250 kilometer square area for 30 hours. Which is giving more depth? 30 hours. What is the meaning of this? Depth is directly proportional to duration. Depth is directly proportional to duration. This is conclusion now. From this we conclude depth is directly proportional to duration. Not saying blindly. I have given one example to you. Easy example. Easily understandable. So by that we conclude depth is directly proportional to duration. Second case, you keep duration of rainfall as constant. Time of occurrence of rainfall is kept constant. Take for example, time of rainfall is 10 hours. The rainfall of 10 hours occurred into area 100 kilometer square area and another catchment with 160 kilometer square area. So which catchment more depth is possible? Which catchment more depth is possible? Tell me. Rainfall duration, time. Rainfall time is not changing, fixed. Same rainfall of 10 hours. happened. These are the two containers. Container of 100 centimeter square, container of 160 centimeter square. Rainfall occurred. Which has more depth? Tell me. Simple. Rainfall is going on now. Now in Hyderabad, rainfall is going on. I placed the two containers of different area. One container is a smaller container, one container is bigger container. I placed it in the rainfall. Which will give more depth? Very good, Rudrajay Singh. More depth is provided by 100 kilometer square. What is the meaning of this? How depth and area are related? Depth is inversely proportional to area. Increase of area decreases the depth. Clear? Depth is inversely proportional to area. So these are the two statements you need to remember. For DAD curve. Clear? For DAD curve, these are the two statements you need to understand. Depth directly proportional to duration. Inversely proportional to area. Now we are plotting the curve. Now I am going to show you how to plot the curve. Okay. On y-axis, what we are taking is depth in millimeter or centimeter. That is up to you, no problem. Units. On x-axis, what we are taking area in kilometer square. On x-axis, what we are taking area in kilometer square. For example, today there is a rainfall. Rainfall depth will not increase, Ajay. Rainfall depth will decrease. So this is the area you consider. 20, 40, 60, 80, 100. Okay. So 20 kilometer square area, 40 kilometer square area, 60 kilometer square area, 80 kilometer square area, 100 kilometer square area. So initially I will start plotting with a rainfall of 8 hours. Rainfall of 8 hours happened in 20 square kilometer area, 40 area, 60 area, 80 area, 100 area. How the curve? Is it a rising curve or falling curve? 10-hour rainfall happened in 20, 40, 60, 80, 100 kilometer square area individually. I need to show on the curve. Is it a rising curve or a falling curve? Falling curve, na 100%. It is a falling curve. Rainfall happened is a falling curve. So this is the depth, rainfall depth for 100 square kilometer. This is rainfall depth for 80. This is rainfall depth for 60. This is rainfall depth for 40. This is rainfall depth for 20. And here we will take 10. This is rainfall depth for 10. Falling curve. Always falling curve only. Na? So this is what the duration I have drawn? 10 hours. Now I have taken, clear, now I have taken 14-hour rainfall. Will it be above 10 hours or below 10 hours line? Second time I have taken 14-hour rainfall. Will it be above 10-hour line or below 10-hour line? Tell me. 14-hour rainfall I have plotted. You understand? Second time, same 10, 20, 40, 60, 80, 100. Duration is changing, Banu, 14 hours. Duration is changing 14 hours now. Yes, above. Above only, na? If you change the duration, the curve is above only, na? This is 14 hours curve. Next I am plotting for 16 hours. This is 16 hours, na? So to be frank, now I'll explain. For 10-hour rainfall, 100 kilometer square area, this is the depth. 10-hour rainfall, 100 square kilometer area, this is the depth. Now, 14-hour rainfall, 100 square kilometer area, this is the depth. 16-hour rainfall, 100 square kilometer area, this is the depth. So it is increasing the depth. With increase of time, depth goes on increasing. That is what we have shown. So regarding DAD curve, one and only very important point, always DAD curve is always a falling curve. Remember this point, very important. Depth, area, duration curve. DAD curve. DAD curve is always a DAD curve is always a, it is always a falling curve, no? Always falling with respect to area, because we are taking area on the x-axis. Clear? We'll move on. Fourth one. IDF curve. IDF curve, we call it as intensity, duration, frequency curve. Intensity, duration, frequency curve. Again, remember it as falling curve. Again, remember it as a falling curve. Same curve, no change. But what we are taking, relation between first what we are taking, kept frequency constant. What is the frequency? What is the frequency? The next time, another time, time of next occurrence of rainfall, frequency, return period. Today one rainfall happened. Again after 2 years that rainfall is going to occur, return period. So that return period, frequency, return period, we kept. For example, that was kept as constant. For example, time is kept constant. Time is equal to 2 years. That was made constant. What is the relation between intensity and the time? Return period or frequency is kept constant. Then intensity and the time. What is formula for intensity we can write? Hi Shruti, after a long time you are attending the classes. What happened these days? Intensity formula we can write down depth by duration. So how intensity and time are related now? We can say it now. Intensity of rainfall. Intensity of rainfall inversely proportional to duration. Inversely proportional to duration. Very good. Bhanu Prakash. Depth by duration. Intensity inversely proportional to duration. Now, duration kept constant. Time you are going to kept constant. Then, frequency. With increase of frequency, intensity increases. With increase of frequency, intensity increases. You are kept constant. With increase of frequency, intensity increases. Because Since last 3 months there is no rainfall. Suddenly one rainfall occurred today. That will give more intensity of rain. Since last 3 months zero rainfall, suddenly today one rainfall occurred. Heavy rainfall, more intensity is falling down. So always frequency of occurrence is directly proportional to intensity. Always frequency of occurrence is directly proportional to intensity. So the same curve we are plotting here, but on x-axis we are taking duration, on y-axis we are taking intensity mm per hour, on y-axis we are taking intensity mm per hour. About this class, this is 5th part. I am planning total 15 parts of hydrology. Okay, Shruti? About hydrology class, total 15 parts for AE, AEE. For AE and AEE only, not for GATE IS. For AE, AEE, I am planning total 15 parts. Maybe it may increase also. This is the 5th part we are going ahead. So intensity and duration. Duration increases, intensity decreases, na? Yes, correct, Ajay Singh. 10 to 14 lectures of hydrology remaining, correct, Ajay Singh. Very good. So, for a written period of 5 years, for a written period of 10 years, for a written period of 30 years. So, it goes on increasing. It goes on increasing. So intensity versus time goes on increasing with respect to frequency, with respect to 5 year, 10 year, 30 year, with respect to 5 year, 10 year, 30 year. So it is also falling curve. So only one point you need to remember here. Intensity, duration, frequency curve. What is the relation between frequency and intensity? Relation between frequency and intensity, both are directly proportional. This is important point you need to remember in this curve. We'll move ahead. Last one. Rainfall double mass curve. The most important and most frequently asking question, two questions we have. Most frequently asking two questions. One is, what is hydrograph? Intensity versus time. Second one is, rainfall double mass curve is used to check. Rainfall double mass curve is required to check consistency of rainfall record. Whether rainfall record given, measured, noted in the rain gauge station, is it correct or not? Whether it is accurate, not accurate. That consistency of rainfall record determined by rainfall double mass curve. What we are taking? Very good question, Anurag. Frequency is after how many years the same rainfall will return. Time. Frequency is the time. Probability. For example, you analyzed flood frequency. Today heavy rainfall flood occurred. You concluded next 2 years, after 2 years this flood is happened. With what probability? 100% probability, 50% probability, 30% probability. That is probability. Chance of occurrence, percentage of occurrence is probability. In the next topic, I will explain in detail, because we have that next topic, flood frequency analysis. In that flood frequency analysis, what is frequency, what is probability, everything I will explain. So rainfall double mass curve used to check consistency of rainfall record, plotted by taking average annual rainfall, average annual rainfall, mean, average annual rainfall mean of base stations, average annual rainfall mean of base stations. We remember cumulative average annual rainfall mean of base stations. Mean of, or you take here, mean of, you take here, mean of. Simply, easily you can remember like this. I will write again, that is easy for you. Mean of arithmetic average or mean of cumulative, here, mean of cumulative normal annual rainfall of base stations versus base stations versus cumulative normal annual rainfall of station X. Just it is a plot of, just it is a plot of cumulative normal annual rainfall of mean of base stations versus cumulative normal annual rainfall of station X. So what we are plotting? Normal annual rainfall, cumulative value of station X, mean or average cumulative of normal annual rainfall of base stations. That plotted curve must be, if it goes on, both will show same curve like this. Curve is perfect, rainfall data is consistent. If it deflects, then this is the error. This is the error happened. You have to estimate the error. Consistency only, Rudrajay Singh, no doubt. Rudrajay Singh, it is consistency only, no doubt. To check consistency of rainfall record only. Okay. Ordinates versus Absika. No. So, average cumulative of normal annual rainfall of base stations versus normal annual rainfall of X. And this theta, variation, inconsistency, error. Inconsistency or error. Okay. We'll go ahead. We'll solve the questions. ISO heights is the line joining points of equal. Tell me. ISO heights is the line joining points of equal. What is the answer? I think everyone can answer it. Easy. Everyone can answer it. It is easy. Equal rainfall depth. Equal rainfall depth. Double mass curve technique is applied to check. What to check? Very, very, very important. I told you already. Double mass curve technique is applied for. Tell me. Rudrajay Singh, this is the answer. Double mass curve. No, not regarding ISO height. I am asking about double mass curve. Double mass curve technique is applied. Yes, very good. To check consistency of records at a suspected rain gauge station. At a suspected rain gauge station. Thiessen polygon method is adopted to compute an area over. An area over what depth we are taking? Minimum depth, maximum depth, instantaneous depth or minimum yield. Thiessen polygon is used to compute an area over. Tell me. Nice, Ajay Singh, you are going to get the job. UPPSC AEE, UPPSC AE, I think AE only this time. So you will get the job and you need to give me treat. So we'll celebrate. Surely you will get, you are very good at answering all questions. Nice. The Thiessen polygonal method is adopted to compute an area over. Only Bhanu Prakash answered. What about remaining people? Only Bhanu Prakash answered. What about remaining people? Mean depth of rainfall. What you are determining through Thiessen polygonal method? Average depth, na? We have written clearly. P average is equal to. What you are determining? P1A1 plus P2A2 and so on by A1 plus A2 plus A3 and so on. An accurate estimate of average rainfall in a particular catchment area can be obtained by. This is very important, most repeated. Accurate estimate of average rainfall. We have average rainfall, different methods. Thiessen polygonal method, isohytal method, arithmetic mean method. What is accurate? What is accurate? So, isohytal method is accurate, most accurate. Isohytal method is taken as the most accurate. Okay, we'll do. Tomorrow we'll solve the remaining problems. So, those who want to take plus subscription, use my code KPCivil. Use my code KPCivil. Take plus subscription as early as possible because yesterday only irrigation engineering. Irrigation is most important for engineering service exam, AE or AEE. Yesterday only that started, course has started. So take using my code KPCivil for plus subscription. And tomorrow class in Unacademy, very important. From open channel flow, hydraulic jump tomorrow 10:30. In Unacademy platform, not in YouTube. This is and YouTube class hydrology for AEE same tomorrow at 4 p.m. YouTube. 2 classes tomorrow you are having. Enjoy the classes, okay? Enjoy the free classes. Tomorrow 2 classes you are having. 10:30 a.m. at Unacademy hydraulic jump. 4 p.m. in YouTube hydrology for AE or AEE. Okay? Done? We'll move on now. Thank you, one and all. Bye bye, all of you.